Look at this question here. We are being told that a wavelength of the blue light changes from 4.7 times 10 power negative 7 meters to 3.5 times 10 power negative 7 meters as it passes from air to water. What is the speed of this light in water? Now, first of all, in physics, we always write down what we are given. That's the first thing you do. Now, we are given here the wavelength of a blue light in air. That is now wavelength of a blue light in air. The wavelength of a blue light in air, we are given, that is 4.7 times 10 power negative 7. That's the first thing. Second thing is that the wavelength of blue light in water, that is 3.5 times 10 power negative 7 meters. Okay, that's the second thing we are given. But also, we all know that the speed of light in air or a vacuum, that is the speed of light in air is always 3 times 10 power 8 meters per second. Don't forget that one. Okay? We always know that. Even if you are not given there, it is always given. So, at this point here, because already we know the speed of light in air, we know the speed of light in water, not the speed, sorry, the wavelength of light in air and the wavelength of light in water. Now, let us calculate what we call calculating the refractive index. Calculating the reflective index of water. Now, for us to calculate the reflective index of water, it will be wavelength in air over wavelength in water. Okay, that's for us to calculate the refractive index. Now it will be the wavelength in air over wavelength in water. Now which it will be the wavelength in air, that's 4.7 times 10 power negative 7 over 3.5 times 10 power negative 7. Now at this point here, now it is going to be 4.7 divided by 3.5. Okay, because this one here, the 2 will cancel. Remember how we do this one here? Indices, that is 10 power negative 7 divided by 10 power negative 7, which is the same as 10 power negative 7 minus 7 because of the division, whereby it will be 10 power negative 7 plus 7, which it will be 10 power 0, which is equals to 1. Now this one here, it will give us 1. So when we take 4.7 divided by 4.7 divided by 3.5, we get our answer to be approximately 1.3429. That is, when we divide 4.7 over 3.5 over 3.5, it will be 1.3429. This is now the refractive index. After finding the refractive index of this one, the next step we need to do is to use the refractive index to calculate the speed of light in water. Now, the speed of light in water is equal to the speed of light in air, over the refractive index, whereby it will be the speed of light in water is equals to the speed of light in air over the refractive index of water. Whereby now it will be the speed of light in air. We always know that it is 3 times 10 power 8 meters per second over the refractive index. Our refractive index, it is here. See it? That is 1.3429. So when we divide that one using the calculator, it will give us 223,397,125.6 meters per second. So when it is per second, this one now it will be approximately equal to the 2.23 times 10 power 8 meters per second. That's now the speed of light in air. Now this 1, 2, 3, 4, 5, 6, 7, 8. Now it will be 2.23 times 10 power 8 meters per second. That's now when we need to calculate the speed of light, the speed of the blue light in water. Now it will be approximately to 2.23 meters times 10 power 8 meters per second. That's good. That's how we calculate the wavelength and the speed in water. Don't forget to share, like, and follow or subscribe. Let us learn together. Have a nice time. Enjoy your day.